What will happen in 2029 when the dreaded asteroid Apophis comes back to Earth? NASA has confirmed its plan, and we need to be prepared because one day the asteroid will come dangerously close to Earth. If an asteroid of this size hits the Earth's surface, it could cause global catastrophes such as massive tsunamis, forest fires, and earthquakes. But how do you successfully fend off a chunk of this size, and what exactly are NASA's plans for Apophis? The asteroid Apophis doesn't just have any name. This monster of an asteroid was named after the ancient Egyptian god of chaos and destruction. In 2004, the space chunk attracted attention when it briefly triggered an asteroid alarm, meaning Apophis was on a direct path to Earth. Can you imagine the astronomers' horror when they first saw the 340 m wide chunk? Initial course calculations confirmed exactly what nobody wanted. The chunk was on a collision course with the Earth. 340 m is enough to reduce a city of millions to rubble, completely incinerate an area of land, and trigger a 100 m high tsunami. This could result in global catastrophes, regional crop failures, or a chain of geological events, such as sudden volcanic eruptions. In 2029, Apophis will come closer to Earth than all geostationary satellites. This means that this asteroid will fly under the satellites and miss us by a hair's breadth. But Apophis will come back. It is a near-Earth asteroid that repeatedly crosses our orbit. Experts suspect that the impact is only a matter of time. For scientists, 2029 will be the year that offers a unique opportunity to collect valuable scientific data and expand our knowledge of asteroids. But that won't be enough to save us. Osiris Apex on its way to Apophis. Osiris is a top-class probe that, after an extremely successful flight to the equally dangerous asteroid Bennu, is now on its way to Apophis. In 2020, the OSIRIS-REx mission successfully collected samples from Bennu, which arrived in the USA in 2023. The reusable probe then became the OSIRIS Apex mission for asteroid exploration. Since its refit, OSIRIS Apex has used the proven technology and experience of its predecessor mission to gain deeper insights into the nature and orbit of Apophis. These samples from the asteroids will help us understand their composition. If we want to fend off asteroids, we need to know exactly what they are made of, how dense they are, how heavy they are, and much more. At the moment, we only have one plan for defense. Asteroids must be pushed out of their orbit. NASA's DART mission showed that this is possible, successfully moving the small asteroid Didymos from its old orbit around the larger Dimorphos asteroid. What do we know about Apophis? It's a relief that we don't have to wait until 2026 to learn more about Apophis, because we have very alert scientists who have already learned a lot about this potentially dangerous asteroid. Let's take a look at the physical properties of Apophis. New observations have shown that Apophis has a much more complex structure than originally thought. High-resolution telescopic images and spectroscopic analyses have revealed variations in its surface composition that are both revealing and lead to further questions. These variations could indicate geological processes, but what processes take place on an asteroid? These mysterious chunks, which very probably date back to the early days of the solar system, are truly enigmatic objects and not just exciting objects of scientific research because we may have to fend them off. Asteroids are flying treasure troves for astronomers, and we simply need to know more about them in order to better understand the evolution of our solar system. By combining radar observations and optical astronomy, researchers have already determined the orbit of Apophis fairly accurately. This new data has helped to determine the asteroid's orbit more precisely and to better estimate the probability of a future impact on Earth. Interestingly, these studies have also shown that Apophis's orbit is influenced by the Yarkovsky effect, a force caused by the uneven heating and cooling of an asteroid. Although the probability of Apophis impacting Earth in the next 100 years is considered low, the long-term risk remains. Future generations will benefit from our research, and the plan for a global asteroid defense will most likely one day result in humanity being well prepared in the event of an impact risk. Even better probes and our knowledge of asteroids could make a successful defense in 50 or 100 years a piece of cake. We also need to know more about gravitational interactions and the aforementioned Yarkovsky effect, both of which can change the orbit of an asteroid unexpectedly. And then, of course, we would have to correct our predictions about the impact probability of Bennu and Apophis. These new missions will include advanced landers or orbiter probes that will be positioned on and near the asteroid. Thanks to these probes, we will know every step of the asteroid, and in case of a collision risk, we would already have important probes in place. For purely scientific purposes, the landers, in particular, will collect detailed data on Apophis's surface composition and internal structure. Some of these missions could also aim to bring more samples of Apophis back to Earth. Imagine how exciting it is to explore the interior of an asteroid and gain unprecedented insights into the nature of a near-Earth asteroid. The fact that we now have the ability to do this alone shows how advanced our civilization has become. Working together to protect the planet. Asteroids not only complete our picture of the universe, they also bring people together. As terrible as the danger is, the willingness for international cooperation and collaboration is impressive. The most important nations around the world are involved in the development of global asteroid defense. The European Space Agency, ESA, and the Japanese Space Agency, JAXA, will contribute probes to the upcoming missions, and further cooperation is planned. An important aspect of future research is the development of strategies to defend against potential asteroid impacts. We need to test impactors that deflect an asteroid from its orbit, and we need to develop further methods to be able to fend off an asteroid by other means. In an emergency, we can only do this together, and every nation contributes something. Some nations' scientists and engineers are working on drilling technologies and lander probes, while others are contributing software for simulation programs or simply much-needed funds. The long-term monitoring of Apophis will require permanent monitoring with powerful telescopes, and here too, scientists from different nations are working together around the clock. Will Apophis bring us closer to aliens? Let's move away from the pure threat and get closer to exploration and curiosity. The exploration of asteroids like Apophis could actually provide key information about the origin of life in the universe, and thus also for the search for extraterrestrial life. How is this possible? Well, asteroids are often regarded as time capsules of the early solar system. Samples that have already reached Earth show that they are rich in organic compounds or even contain prebiotic molecules. Bennu contains a whole range of amino acids, which are the basic building blocks of life. If we were to find these minerals and amino acids on a planet like Mars, they would be traces of life. But we find these building blocks on asteroids of all places. So, the question arises, how did they get there? When did they form, and how did life come to Earth? Amino acids and organic molecules don't just grow like that. They must have an origin. And if we get closer to this, it could expand our understanding of how life develops and whether similar processes might also take place on other celestial bodies. The study of Apophis, therefore, also offers a unique opportunity to study the conditions under which life may emerge. By studying its surface, its geological features, and the effects of radiation and microgravity, scientists can develop models to understand the viability of life in extreme environments. Asteroid research is, therefore, currently bringing together scientific disciplines such as astronomy, geology, and biology in an exciting way. Bennu did not provide any direct evidence for microbes or the like, but it did provide virtually all the building blocks for life. Who knows what we will find on Apophis if we dig there long enough and have the appropriate probes on site. How was Apophis formed? The magical thing about asteroids like Apophis is their origin in the early days of the solar system. They are most likely the last remnants of the dust and gas cloud from which our sun and planets were formed, and they have most likely hardly changed since the beginning of the solar system. By studying their composition, scientists can gain insights into the conditions and processes that led to the formation of the planets and other celestial bodies. Apophis, like all asteroids and comets, is a living window into the past. Most asteroids were bound to planets or special orbits in the course of the structuring of our solar system. Thousands of these chunks are bound in the asteroid belt between Jupiter and Mars. Many more can be found in the Kuiper belt behind Pluto and far out in the solar system. Plus, countless comets can be found in the Oort cloud, which has hardly been researched to date. Both asteroids and comets are magnetically attracted to the Sun from time to time and then wander through the solar system. Near-Earth asteroids, including Bennu and Apophis, constantly orbit the Sun on a path that repeatedly crosses that of our Earth. The asteroids, therefore, do not target us when they are on a collision course, but simply come close to the Earth's orbit when they are on their usually very irregular orbits around the Sun. An impact wouldn't be a nasty attack from space, it would just be a silly coincidence. If you love amazing videos, subscribe to the channel now.